Great. Hi, so just a really quick introduction. My name is Ehi. I work for Microsoft. I am a machine learning scientist and manager at Microsoft. I work in the Cambridge, Massachusetts office, so on the East Coast. We're headquartered in Redmond, so I have a small office right here on the East Coast. Well, not too small, but it's okay, on the East Coast. Yeah, so I got into machine learning when I did my PhD. I did my PhD at MIT in computer science, and I worked in the field of machine learning, looking at healthcare, and how do you make people feel better? How do you make people, be more aware of their well-being and wellness, and how do you use data and machine learning to accomplish that? And that's sort of when I started to get a little bit more aware of machine learning and its biases, and just some of the problems that it can cause. It's really great technology, but it just gave me a little bit more of an awareness because when you're looking at healthcare data, it's no longer just a statistical point or a data point. It's like a human being, right? And so you're just more aware of those kind of things when you're working in the healthcare space. Right after I finished my PhD, I joined Microsoft. Still the same goal, how to use machine learning to make people use our products better. How do you understand user experience? How do you improve so that you can just get the best out of the products? And so that's where I have been now, and I have been, it's been a good time. So it's supposed to be a very brief introduction to AI, and just talking through how to use data and encode bias, how it uses data, how we can use data, and how it encodes biases. I'm very light on the PowerPoint because I really wanted to give some time at the end for questions and discussions because I wasn't quite aware, or I wasn't quite sure what the background of the group was, or what kind of questions I'll get. So is that okay?
That'd be great, please. Yes.
Okay. So moving on. I found this quote that I thought was really interesting because in some way it just really summed up what AI is. It is a computer system that can perform tasks, or I would edit it and say it tries to perform tasks that would ordinarily require human intelligence, because we're definitely not at the level of human intelligence yet. And these AI systems are usually powered by machine learning. And some of them can be powered specifically by deep learning, and some of them can be powered by really just rules or heuristics. Like it's very shocking to see just how sometimes some of those algorithms are really just rules, as opposed to like the more powerful machine learning or the more powerful deep learning. So when you think about an AI system, it's really just a computer system, and it tries to mimic as much as possible human intelligence. That's the goal, right? Let's try to get to a point where computers can think and act like human beings, in order to make life better for everybody. Artificial intelligence is like this really broad topic or landscape, or it's like a broad field, right? It's any technique that enables humans to mimic human behavior. And in a subset of AI, you have machine learning, which is statistical methods that enable machines to improve experiences. And then as a subset of machine learning, you have what's now called deep learning, and it's a subset of ML that uses like neural networks. So they try to really mimic a lot close to the brain and how the brain and the neurons are connected and how all these things work. And so these are really just AI is the broad umbrella. Then you have machine learning, then you have deep learning. There are other AIs that are not machine learning, for example, but going forward, just because like ML is like the most common, I would be using ML and AI interchangeably. So when I say AI, I mean ML. Just because like this is what's most common, this is what's most available right now. So a very, very brief introduction. The goals of machine learning is very simple. Let us learn patterns from data, right? You're given this data set, which is typically the training data. I don't know if you can see my pointers, but that's the training data. And you want to train a machine learning model. And when you say train a machine learning model, you're really just trying to understand the patterns in the data. And once you train the machine learning, the outcome of that is a model, right? You have a model that is really just a statistical equation that has learned all the patterns in the data. Maybe it knows that if you give it X and Y, if you add them together, you get Z. That could just be the pattern it has learned. And that's sort of what it has learned from the data. And typically, once you've learned patterns from the data, you want to be able to predict an outcome. And so once you have this model that is trained, you give it an input data, and you have a prediction. So let's say, for example, we want to predict whether or not an image is a cat, right? You would give this model several images of cats, of dogs, of, I don't know, alligators, whatever, just several images. And each of these images would have a label or have a tag that would say, this is a cat, this is a dog, this is a, alligator, this is a, I don't know, bear or something. And the goal of the model is to be able to learn the patterns of what cats look like. What is a cat? How does it look like? And so once you've trained the model, then you give it brand new images that it has never seen, which is the input data, and you ask it to make a prediction. What is this, right? And oftentimes the model will get it right. If you've done the right things, if you have trained the right models, if you've put in the right data set, the model will get it right. But sometimes it doesn't get it right, right? Maybe you can have a cat that somehow looks like a dog and it really can't differentiate between the two of them. Or maybe it has only seen like white dogs, for example, all of a sudden this is a black dog or a gray dog and it really doesn't know what that is. And so maybe it calls it an alligator or something. I don't know. And so part of the process of an ML model is being able to improve the algorithm. And so you usually go through some evaluation method where you're saying, okay, this is input data. What are you calling? How do you differentiate between these animals? If it doesn't improve, you tighten the rules, you send it back. And so it becomes a really big feedback loop where you're training the model, you're evaluating, you're predicting on a new data set, and you're trying to improve. So it learns patterns from the data, it tries to predict an outcome, and then you improve the algorithm. That's like the very three simple goals of machine learning. And of course, predicting an outcome is super complicated depending on the model that you have. You can have a very simple model that just says, you can have a very simple model that just says, oh, let's look at yesterday's event, for example, and it's the same as today's event. As maybe we want to forecast the weather. A simple model can just say, oh, yesterday's weather is today's weather. Or a simple model can say, hey, we're in the middle of February. Let's look at last year's February's information and figure out what today's February should be, right? And so it really just depends on the model you have and what kind of task you have at hand. There are different types of machine learning. You have supervised. So when I talked about the cats and trying to identify cats and dogs, that is a supervised method, right? Because you have given it a picture of a cat and you tell it this is a cat. And so it's a lot easier for it to make that connection. Now it just needs to put those two things together and understand the patterns that connect these two things. We also have unsupervised methods where you don't really have labels, right? You don't really tell it as a cat, but you just give it a bunch of pictures and then it starts to learn like, oh, wait, all cats have whiskers, right? And so it starts to look for pictures with whiskers and group them all together. Or it's like, oh, dogs have this really long tail, right? So it's looking for long tails and it brings it together. So those are unsupervised approaches. They're a lot harder to do, and they're only suitable for certain kind of tasks. And of course, we have another one, which is reinforcement learning, where it's more like an active learning. You want to learn from, like you take a step, you learn from it, you take a next step, you learn from it, and you just keep reinforcing the agent as you go along. So these are like, in a nutshell, a very brief introduction to ML. What are the goals? Learn patterns, predict an outcome, and improve algorithms. I think I'd like to stop here if there are any questions. I can't see people, so I don't know if you're confused or.
Nosakhare. I don't know. I hope I didn't pronounce that.
It's Nosakhare.
All right. I was working with a young lady that was actually doing something similar at City Miami Beach. She was analyzing cats' faces to actually identify all the strays that haven't been neutered, and she has a pretty high rate of success with it. So I think it's a good project because it shows a project that really would be of interest to girls because it's a societal issue. Sort of broad stroke, not the typical robotics where I come from, where it's very limited.
Yep.
What I love about AI is it opens so many doors. There's so many possibilities.
Yeah, absolutely. A lot of the so when we talk about like identify cancer dogs, that's a subset of AI called computer vision. And a lot of the models were trained on images of cats and dogs. Like that's how we train those models. To learn and be able to differentiate and segment images and all of that stuff. And it's amazing how much it does now, like, identify cats and dogs have moved all the way to facial recognition, which is something I will talk about later.
I have a Well, I have a couple questions, but and
Hmm.
yeah, I know you want to say a couple more things. We're we're gonna we're going to look at some other, not only just uses, but ways that machine learning has continued to evolve and where it's going, where it's coming from. I
Hmm.
guess one of my questions would be, um, Microsoft and all the large companies, and every company I'm sure knows about the ramifications, the possible, you know,
Hmm.
positives and negatives of having machines learn and continue to learn. I guess
Hmm.
I'm sure there are. Um, I'm sure there are checks and balances for where we're going, how, when we're going too far. I'm sure these things come up a lot, but could you touch on just for a minute where, because it's going to scare some people, right? How
Oh
we're
yeah.
we're we're we're, we're teaching machines and they're getting smarter and smarter by the
Hmm.
second. We're feeding them information.
Hmm.
How does that being thought about?
Yeah, absolutely. That's like the second half of my presentation.
Oh, okay.
So you
Perfect.
great segue
Great. Okay.
into the impact of AI. I don't have slides that talk about like sort of where we're going and how we think about it, but I will definitely talk about it. But I do have a couple of slides that highlight some of the problems that we're starting to see. Um, and so the thing is, because AI has become really successful, or machine learning, whatever you want to call it, it's becoming to have a very considerable, like huge impact on businesses and society as a whole. I think it started out having impacts on businesses because obviously, they pay for this technology and, they want to make money. But very recently, we are starting to see the impact it's having on society. And it's all the same thing, right? We think about how when we started to have airplanes, they were great. But now we're realizing like, oh, wait, climate change, maybe not such a great idea. Right. And so that's sort of where we are with AI and the impact of society. You see AI being used in energy, right? How do you generate more efficient energy? Companies are partnering with oil companies to make sure they're drilling effectively, they're drilling in the right places, they're getting, the best bang for their buck in terms of making sure at least oil exists in this portion of land before you even drill it. So we're minimizing its impact on community. You see AI being used in healthcare. How do you monitor the elderly? How do you monitor the sick? How do you prevent, most people have like, one of all the smart watches and you have AI trying to figure out, how healthy are you? Are you active? Detecting your heart rate, things like that. And even in agriculture, right? How do you monitor the weather such that you plant your crops at the right time? Or how do you, make sure you're irrigating the right way? Things like that. There's a lot of it's everywhere. But unfortunately, it's also raising a host of like complex questions and very challenging questions. So, for example, one example that happened a while back was in automated recruiting, right? Where it, some news article had um, assessed the company's automated recruiting pipeline and realized that there was a lot of biases that was happening. I think at the time, for every like 10 people who were applied, for example, like 80% of the people who were picked were men, right? Women were being ignored. 100% minorities were being ignored by the algorithm. And so it was pretty bizarre. It's also been seen in the criminal justice system, right? You have, I think ProPublica did an article a couple of years back where they realized that judges were using this algorithm to predict which person would go on to complete a crime, and that would determine whether or not they were going to get bail. And something as bail is really important, right? If you're on bail, you're outside, you can defend yourself, you have access to lawyers, you have access to resources. But if you're on the inside, maybe you have access to your lawyer 1 hour every 24 hours, right? And you can see how, and if you can't afford bail, chances are you cannot afford a good lawyer. And so it's just like, it cascades into all this host of issues that you don't necessarily see. And the analysis that, ProPublica had actually done was that a lot of the Black men, for example, that were predicted high risk did not actually go on to commit crimes. While on the other hand, Caucasian men actually did go on to commit crimes in a very higher rate than, the people who were actually predicted in the first place. And so there are issues like that, right? And it's able to encode biases in this system. Also in the financial industry, this one was really huge at some point where we realized that the algorithms was learning zip codes and using zip codes as a proxy for race. And in communities where you had majority underrepresented minorities, it was denying loans to them because those communities are usually deemed undervalued, or maybe they don't have, those properties are not very valuable, and then you just assume they don't have enough income, and then it's just like not even give them loans in the first place. And so it can really, what we were starting to see is AI is able to learn from the biases that we have in society. And the reason for that is pretty much because AI uses data. There's a term we always talk about, garbage in, garbage out. So it's like, it's what you give it, that's what it's going to learn. And so pretty much how you start with the problem is like you want to frame it. And usually when you're framing a problem, you're usually doing that for business reasons, right? For the person in the financial industry, you're trying to optimize who should get your loan so you can get your money back. You're really not thinking about people. You're really not thinking of, it's hard for me to monitor the chat, so please unmute and ask me a question if you have a question. It's okay to have a discussion. You're really not thinking about human beings, right? If I was a personal loan officer and someone walks in, I can be a little bit more sympathetic or empathetic. If it's an algorithm, it's just a bunch of numbers, right? And you've optimized for the profit for the bank. So it's going to look for the quickest way possible to do that for you. And then the other thing is, when you're collecting the data, right? So at this stage, the bias really comes up when if the data is collected and is underrepresented, is not representative, right? And or if it also reflects existing prejudices. In the case of the loan case, you are collecting data from people who have already been refused loans based on the biases in the society. And they're using that to train a system. And so that system is going to learn that pattern and will continue to refuse loans to people who have been refused based on biases in the society. Also, if your data is not representative, this is one case study that I'm going to talk about in the coming slides. Like if you, for example, like I said with the cat and dog situation, if you've only trained your model on how to identify cats, it would never know how to identify a dog. It's just never seen the dog. It doesn't know what it is. And so if you put it in a situation to identify a dog, it's not going to do very well. And in the situation of just identifying dogs and cats, it might not really, have an impact. But when you start to use this kind of recognition systems in criminal justice, in figuring out who has committed a crime, figuring out who needs to pay a fine for a traffic cam or something, then you start to affect people's lives. And you need to be a little bit more careful. Bias can also be introduced when we prepare the data, because typically you have a bunch of data. So me as an individual, when I get a data set, I know what my objective is. Then I start to select, right? It's a lot of data. You really cannot use everything to train a model. So my biases are also introduced into that process, right? Because left to me, for example, in Boston, if we want to buy a house, there are certain things I think that are important. And so those are the things I would pick in the data set. Down in Florida, there are completely different sets of qualities that you probably look for in a buyer, right? And so if there's a data scientist in Florida, they will probably pick a different set of features in order to predict who wants to buy a house in Florida. And so of course, in collecting the data, there's a problem. When you frame the problem initially, there's already some bias introduced. Once the data is collected, there are several biases introduced. When I am preparing the data for the model, there are several biases introduced as well. And so these are just the spectrum, right, of ways bias can be introduced. And that is why we start to see these problems in society. And so I wanted to use this case study about when the data is underrepresented and how that can introduce biases. This is actually a study that was done at one of my colleagues while back I was at MIT, and it made a huge splash because she wanted to use the facial recognition system to do something. I can't remember what she wanted to do, but she was, usually you have all these APIs, you log in, you put in a face, it identifies whether you're a man or a woman, how old you are, what your agenda is. And she wanted to use it for some end application. And she's a really dark-skinned girl. She put on this facial recognition system and it could not identify her face. It just threw a blank, right? There was no face detected. And so she was like, what's going on? And she put on a white mask on her face, like a legit white mask, which is a white, like all this white Halloween mask, and it detected a face. It was like, white face, and so she was like, what is going on? And she started to look at the 3 most popular APIs for facial recognition at that time, which included Microsoft, Face++, and I think eventually they added on IBM. Yes, IBM was the 3rd one. Microsoft, Facebook was IBM, and so she gathered a data set, a more representative data set. So she looked at women across the different spectrum of color, looked at men across the different spectrum of color, looked at, gathered a more representative data set, and then used this APIs to identify faces. And the biggest error, there were errors across the board. White men had the most. I think it was like 99% accuracy on white men. I think white women had like maybe in the low 80s or something. But Black women were like in the low 60s in terms of accuracy. And so it set up a chain of events. It was a really huge, I have the link of the article here. It was a really huge thing where the companies were now forced to defend their software. Like, what are you doing? Like, if you're making the software available to the public, you're selling it as an accurate system. Why isn't it being able to be accurate on everyone? And it turns out that what had happened was the data sets that they had used to train these models were not representative. A lot of times, if you look at the facial recognition data sets, and I understand, I'm in grad school, right? A lot of all these data sets are built by graduate students, and you almost always go through the path of least resistance when you're trying to do things like this. And so you end up collecting data sets of your friends, your colleagues, people around you. You're not really thinking about like, oh, this is eventually going to become something that Microsoft will use, right? Or IBM will use, right? And these data sets become benchmark data sets, and they go out there and they haven't just seen the whole population, but then these algorithms are trained on them, and then they're used to predict on the whole population. And if it was just an issue of, oh, let's just predict faces, of course, right? But people have actually found that over 117 million American adults are in facial recognition networks used by law enforcement. And African Americans are almost always likely to be singled out by these things disproportionately. And so you start to see issues with this, right? If you're using these APIs that are not very well trained and not very well represented, and they're used to make criminal justice recommendations, then you have a problem, right? If you're just identifying faces, oh, sure. But once you start to impact people's lives, you have a problem. And this is one of my very best quotes. It's written by Brad Smith, who's the president of Microsoft. And he talks about how when your technology changes the world, you bear the responsibility to help to address the world that you have helped create. And so to answer your question, Daniel, about what Microsoft is doing, we've come up with 5 principles of what it means to develop AI responsibly, and we call it responsible AI. Making sure that the AI system is fair across the board, is interpretable, you can understand what it's doing, or at least explain what it's doing to a human, so you know what, the inner workings of the algorithm. We also want to make sure it's trustworthy, so people understand, so people trust it, right? And then we also want to make sure it's what's the word? Well, that it's safe and secure, so people can't hack it or cause problems down the line. Yeah, so that's sort of the end of my presentation. I'll try to answer some more questions at this point.